I've got myself an electron in the system. I got a proton and I got myself my electron, and I guess two. Okay, so here's my proton, here's my electron. We already have an idea what those fields look like for that proton. Okay, everything is positive, so the fields are coming straight out, and they're coming out radially. Okay? What about an electron? Well, KQ over R squared, the equation for this, but we know an electron carries a negative charge, so that Q is a negative value. So what does that mean for the field lines? Well, that means that the field lines are not radiating outwards, they're radiating inwards. Something like this. They're getting pulled towards the center, or getting pulled towards the electrons. That means if I drop a positive charge, what happens? Well, it gets pulled towards the electron, and it turns out the electron is actually pulled towards the proton too. Okay? It has to be Newton's second law. Or not Newton's second law. Duh. Newton's third law. Okay? So you have the interaction here between charge 1, charge 2. This one's creating a field that's being sucked in. This one's creating a field that's being pushed out. So positive charge means that a positive electric field. Negative charge, this electric field is collapsing into that electron. Okay? So what that means is if I were to draw my field lines with the interaction and talking about superposition again, I'm not going to get that cancellation. I'm going to get cancellation in this direction at that point, but my field lines are going to end up looking like this. There's a high tendency for objects to come together. I drop a charge in here, make it a positive charge, whang! It's going to slam right into that electron. This object's going to push it, this object's going to pull it. These vectors are huge compared to these vectors. You have all of this potential force, if you will, this waiting to happen force in this direction. Okay? Tremendous amount of pressure to move it in that direction. Cool? So that's what it would look like if I were to introduce an electron into a proton. The field interaction here. You're going to get this reaction something like this. Okay? Cool? That is fields for electrostatics. I will do a demonstration for gravitational fields. And then we'll talk about potentials and energy.